So here's another quick, simple example applying nodal analysis. So in this case, they're wanting us to derive equations to solve for the four node voltages. And in particular, they're wanting node 4. So what's the voltage at node number 4? And we need to also note that in this case, all the resistors are given in Siemens, so that means it's conductance, not resistance. So instead of dividing by that, we would multiply by those. All right, so let's go about this and see how this works. So the first node we want to look at then is this node 1. So remember, we're defining current leaving a node as positive, and we're summing up all the currents leaving and entering a node. So then in this case, if we look at this, we have a 2 amp source entering. So therefore, that's going to be a -2. Next, if we come down to 2 amp, it's 1 amp, 1 Siemens, 1 Siemens resistor, then this will be plus 1 times V1. And then finally, if we come around to this one, this resistor here, that's going to be plus V2, that's going to be 7 times V1 minus V2. And so that takes care of all of those and all the branches in that node, so that can be set equal to 0. So let's pick our next node here. We'll use this one. So in this case, we already have the 7 in purple, so that'll be 7 times V2 minus V1. And then coming around in our color chart, we use this 2 Siemens resistor. And so we can rewrite that one then as plus 2 times V2. And then we have this guy, this current source, is coming straight into our node. So since it's entering our node, it will be negative. So it'll be a -1. And that's all of the branches for that node. So set that equal to 0. So now coming around our color chart here, let's do V3. That'd be the purple. We can see we already have that green current source. It's leaving our node in this case, so that means it'll be a +1. All right, and so then we can look at this device here, 6. So that's going to be plus 6 times V3. And then finally, if we come around to this next device, and we'll make that one, I guess, green as well here. So that's going to be plus 4. Now, let me use the right color here. Green plus 4 times V3 minus V4. And that takes care of everything going out of the purple V3. So we can set that equal to 0. And then finally, we'll say V4, which will be in green. And we have our first component, which is the 4 Siemens conductor or resistor. And so that'll be 4 times V4 minus V3. And then we here. And so that'll be plus 5 times V4. And then finally, we will have this current source, and it's entering our node, so therefore that makes it negative. That's minus 9, and we can set all of that equal to 0. So next we need to combine like terms and rearrange things just a little bit. So when we do that, again, just algebra here, we'll get 8v1 minus 7v2, and that's going to be equal to 2. For the next one, it'll be minus 7v1 plus 9v2, and that'll equal to 1. Then we'll have 10 times v3 minus 4 times v4. That'll equal to minus 1. And then finally, we'll have minus 4 v3 plus 9 v4, and that's equal to 9. So then we should be able to create our matrix here. So it'll be 8 minus 7, 0, 0, minus 7, 9, 0, 0, then 0, 0, 10 minus 4, and then 0, 0, minus 4, 9. Again, these are times v1, v2, v3, and v4. This will be equal to our answer array, which is 2, 1, minus 1, and 9. So now again, using whatever method you choose, you can divide that into that. And when we do that, we come up with V4 is equal to 1.16 volts. So this is what they ask us to solve for. And so that's what we have. And so that is the voltage at that node.